Hey everyone, my name is Jenny Men. I'm a solutions architect and a developer advocate in data engineering. Today, we're going to go over how to load data into Snowflake with a brief introduction of the Snowflake UI. We'll also go over how to scale compute and a bit about working with semi-structured data, JSON, and how to access data via secure live shares and the Snowflake data marketplace. We'll also briefly touch on how to create data visualizations and building and sharing dashboards on Snowflake. The data we'll be using for this demo is City Bike data. City Bike is a bike sharing service. We're going to be focused on data in New York City, and the data we'll be dealing with is about trips and stations. We're also going to bring in some of our own weather data to augment these data sets. In the Snowflake UI, you can see that our demo user is signed in with a DVA City Bike role. I'll go through these tabs here. The first is the Worksheets tab, and we'll get into what a worksheet is in a little bit. We've got dashboards, which we'll also talk about later. Under the Data tab, you can see your databases, and you can drill into these further to see schemas, tables, views, etc. This is also where you'll get access to the data marketplace. The Compute tab is where you're going to manage your warehouses. At Snowflake, we separate storage and compute. Compute is what's actually doing the work on your data, whether it's loading it or transforming it or querying it. When you create a warehouse, you'll give it a name, and you're going to choose the size. An extra small is a one-node cluster. And you'll see that with each step up, the number of resources doubles. Now, Snowflake charges per second. So if you have an extra small running for 1 hour, you will see that it consumes 1 credit. We also have multi-cluster warehouse. In this situation, Snowflake will start off with 1 extra large warehouse. As users, sign into the system and start using this warehouse. We don't want there to be resource contention and the degradation of performance for those users. With multi-cluster warehouse, Snowflake will automatically spin up an identical extra large cluster and balance the queries between the two. It can do this up until 10 clusters, so that end users see no degradation of performance, regardless of how many users are accessing that warehouse at the same time. And just as Snowflake automatically scales out, it will scale back in when those resources are no longer needed so that you aren't paying for them unless they're being used. Let's get into the demo. We're going to start off by loading some trips data. So we've set up a stage where we've staged 232 CSV files. We'll see that this data as a whole represents about 2.2 gigabytes of compressed storage. I'm going to create a table for this to land in. And I'm going to go ahead and start copying data into this table. You'll notice that I'm only copying data from 2020. And if I look at my warehouse size, my load warehouse is a small from this dropdown. So we'll see that we loaded 40 files in just about 12 seconds. These equate to about 20 million rows. But if you remember, I had 232 files in that stage. And I don't want to wait for all of those to load. So you can see within seconds, I can scale this up to a large warehouse. So I went from a small to a large, which is a 4x increase in compute resources. Now I can copy in the rest of the data. And you should see that it runs in about the same time, maybe a little bit longer. And we're going to load in the remaining 192 files that were in that stage. There we go. We can see we loaded 192 files in 13 seconds. Now that I'm done with that, I can scale the warehouse back down to a small because I don't need the larger resources anymore. You can see that I now have about 116 million rows in this table. And if we take a look at the data, it's just data about the trip. So how long they took and where and when they started and stopped. I've also got stations data that I've already loaded in. And I've got weather data. And what's interesting about this table is it only has two columns. One is V, when this holds the entire JSON file for this weather record. But what's really interesting in Snowflake is that I can use basic SQL to query this. So using a simple dot notation, I'm saying go to the V column, go find a city key, find a name key, and then cast that value as a string. I can start pulling data out of this JSON file without actually changing the underlying file at all. Now I'm going to go ahead and I'm going to change my warehouse to an extra large. And I'm going to build a view that combines the trips data and the stations data together. We can see that now, instead of just having the station ID, we have information about where the stations are. And now I can add in my weather data. And again, this data is still stored in its native JSON format. But I can pull out the values I need into this view with basic SQL syntax. So if I scroll over, you see we still have our trips and stations data, but now we're also pulling in weather data, even though we haven't changed anything about the data as it's stored in Snowflake. What we could also do is we could go to the data marketplace to find weather data. So I could go to weather, I could find free data sets, and I can bring these into my environment very easily. I can click Get Data. I'm going to simplify this and just call it weather. And I'm going to make it public for everyone to see. Accept the terms and conditions, and that's it. It's all done. So if I go back to my worksheet and I refresh the page, you'll see that I now have access to this weather database and all of these views that I have access to. I can query as if it's my own internal data. And I can combine it with data. And again, once I set up the share for the first time, I don't have to manage this to keep it up to date. When WeatherSource updates the data on their side, I will automatically see the updated data in my environment. In Snowflake's new UI, we also have some light visualization tools. You can see I ran a query here and I got the results back. On the right, we have some light visualizations where I can do some data discovery and drill down. And I can also build out some visualizations. So here, I'm just mapping the number of trips per day over time, and I can change the bucketing so I can do it on a daily basis or a weekly basis or a monthly basis. And then once I've created this visualization, I can add it to the dashboard, where I can now see all these visualizations that are pertinent to the CityBike data on one screen. Thanks for watching. Subscribe to this channel for upcoming content on how to start or build a career in tech, how to automate using low-code RPA, how to build real-time low-code data pipelines, and other tech content.